Okay, so today I'm gonna do the AMC 8 2020. I've never done a previous math competition, and I am 17 years old. But I think this should be kind of interesting. I've done practice problems from AOPS. It's like a year ago, I remember. So I think I did an AMC 8 practice thing before when I was bored. So yeah, let's start. We have 40 minutes to do it, so I'm gonna try to do this in 40 minutes. Hopefully I can do it. Let me see if Microsoft Paint works. It's working. Okay. Let's just like maybe that's a bit too big, but it's okay. Okay. 3, 2, 1, go. Okay, let's go. Alright, Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water. Wait, Luca's making lemonade. His recipe requires 4 times as much water as sugar. So sugar equals 4 water. 4 times as much water as sugar, and that line equals 2 sugar. Here he uses 3 cups of lemon juice. So how many cups of water does he need? So 3L equals 6S equals 24. So it's E. But let me make this a bit thicker. 5. Okay, yeah. So I think it's 5. Or it's how many cups of water does he need? I think it's E. Okay, let's go. Alright, so we have 4 friends do yard work for their neighbors over the weekend, earning 15, 20, 25, and 40. They decide to split their earnings equally. How much will the friend... Okay, so 15, so 20, 45, 85, 90, 100, that's 100. 100 times 4 is 25. So 40 minus 25 is $15. So we'll give $15 to others. The friend that earned $40 will give $15 to others. Let's go. How much time do I have left? Okay, that was like... Okay, Carrie has a rectangular garden that measures 6 feet by 8 feet. What the frick? Why is it like that? Okay. So 6, 8 by 8 feet. She made some kind of strawberry plants. Carrie's able to plant 4 strawberry plants per square foot. She offers another 10 strawberries per plant. So 6 is 32. Wait, no, 40. So it's 48. So that's 48 square feet. So then 48 times 4. That's 1 60 plus 32, 192, 192, 192, so it's 920. I should probably save this, just in case. Downloads. AMC 8 2020, yeah. Okay, let's go. Windows Shift S. Three hexagons of increasing size are shown below. Suppose the dot pattern continues so that each successive hexagon contains one or more band of dots. How many dots are in the next hexagon? So it's 1, 2, 3, 4, 5, 6. Wait, what the fuck? 1, 2, 3, 4, 5, 6, 7. Okay. So then it just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, so it'd be like 1, 2, 3. So it's like, wait, am I stupid? Wait, just do 1, 2. So it'd be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18. 18 plus, so it'd be 18 plus, it's 1, 2, so 7, 1, 2, 3, 4, 5, 6, 7, 8, wait, no, 1, 2, 3, 4, 5, 10, so 12 plus 18 is, how many dots plus 7? So that's 8, that's 10, 37. I'm stupid. Okay. Alright. 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring equal amount of juice into each of what? Okay, wait, so 3/4 is 75%. So use 3/4 divide by 5. That's 3/20. Yeah, 3/20. So that means 75 divided by 5. 75 divided by 5. 15? Yeah, 15. 15%. Wait, yeah, 15%. 15, 30, 45, 50, 75. Yeah, okay, that makes sense. Oh my gosh, wait. Okay, let's go back up. Wait, can I go down? No, I can't go down anymore. Hopefully this canvas should be in big enough. Aaron, Darren, Karen, oh, what the? Aaron, Darren, Karen, Marin, and Sharon rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car, so there's like 1, 2, 3, 4, 5. So Marin sat in the last car. What the? Okay, wait. So, what? So Marin sat in the last car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. At least one person sat between Karen and Darren. In front of Aaron. So it has to be like. So if this is Sharon, this is Aaron. Wait, what? 5 car has 5. 1, 2, 3, 4, 5. So that means this is Aaron. This is Sharon. Wait, what? 1, 2, 3, 4, 5. Sharon. Darren sat one of the cars in front of Aaron. One person sat okay, so wait, what? Where's Karen? Marin sat in the glass car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. So it means Darren sat here. At least one person sat between Karen. Wait, what? So Marin, Aaron, Sharon. So it's Karen and Darren. Wait, what? 5 cars. 1, 2, 3. Wait, how does this work? So there's Aaron, Darren. So there's A, D. I'm stupid. D, K. Am I recording even? Okay, I am recording. Marin and Sharon rode on a small train that has 5 cars that seat one person each. So there's 1, 2, 3, 4, 5. So Marin sat in the last car. So Marin is here. Aaron sat directly behind Sharon. Aaron sat directly behind Sharon. Darren sat in the cars in front of Aaron. At least one person sat between Karen and Darren. Wait, so if we assume Aaron is here, that means Sharon is here. And then Darren sat in one of the cars in front of Aaron. At least in the cars. Wait, what? Darren sat in one of the cars in front of Aaron. So it means Darren here. And one person sat between Karen and Darren. Wait, then who sat in the middle car? I actually don't know how this works. I think I'm gonna skip this. I think I'm stupid, but like I don't understand. Yo, what is this mouse doing, bro? Okay, let's just put this here. How many integers between 2020 and 20 have 4 distinct integers erase increasing order? So it can't be. So let's start with 2, 1. So it's like, oh my gosh. So it's 2, 2, thing. So this can be either increase. So it can't be 1. It has to be either 2, 3, or 4. But it can't be 4 because 4 doesn't have increasing. So then, with 2, arrange increasing order. If it's 2, let's do like, wait. If it's 2, then it has to be, it's either, let's just assume it's 2. If it's 2, then it can be 3, 4, 5, 6, 7, 8, or 9. Yeah, so then Wait, this is like combinatorics. Wait. So there's. So this is like the max. 4 is the max. So there's this possibility, and then there's 1, 2, 3, 4, 5. So there's these possibilities, but like if it's like 3, then it can be 4. But if let's say it's like 7, then it has to be 8 or 9. It can only be 8 or 9. Wait, so it's like this is like n. So then this would be n. The possibility 1, 2, 3, 4, 5. So if it's like, let's say if it's like 8, that means there can only be one. So this would be n minus 1 factorial. And in this case, n is. Wait. 1, 2, 3, 4, 5. So it's like 1. So it's like n factorial times n minus 1 factorial. Am I right? I think I'm just 1, 2, 3, 4, 5, 6, 7. So it's 7 factorial times 6 factorial plus. Wait, that doesn't seem right. So it can be this one, and then no, it's not that. So let's say we do. Let's say we do 4. Okay, let's say we start with 5. We have 5. Let's say like the number we have is 5. So then 5, there can be only 6, 7, 8, or 9. So there's this possibility, and then there's n possibilities. There's 7 possibilities, right? And then each possibility leads to 7. So this is 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. The possibilities is 9 minus n, with this being n. Right? Like if we choose. Wait, what? Okay, let me think. So let's say we do 5. Then we're going to do 6, 7, 8, 9. So that means this is one possibility. This is 4. No, so this is 4. Wait. So this is 4. That means this is 5, so it's 6. So it's a 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. So then you cross this off. So then, wait. It would be adding together because you're trying to know the total amount of possibilities. Yes. So this is 6 plus 5. Yeah, and it makes sense with this. Okay, so it's 3. So this is 10, 15, 21. That's 21. And then if we do 2, 3, we can only do 4, 5, 6, 7, 8, 9. You cancel out 9. So then this is like, this would be 5. If you do this, 1, 2, 3, 4, 5. So this is 5 plus 4 plus 3 plus 2 plus 1. So then this is 6, 10, 15? 21 plus 15? How many integers between 20 and 20 have, for example, wait, so there's like 2, 2, 3, 4, 2, 2, 3, 5, 2, so it's like 2, 2, 3, and then this can be from 4 to 9, and then it's like 2, 2, 4, 5 to 9, and then 2, 2. Okay, so it's like 2, 2, and then a number n between 3 to 9, or no, 3 to 8, 3 to 8, and then another number will be, the next number will be n from, it'll become n plus 1 to 9. So this would be to 9. So you have the number n. So if you so we have 3, so it's 5 numbers, that means, and then each number is like, you have 5 numbers and each number is multiplied by, so it means you have 5 possibilities, and then each of the possibilities is one of these. So then this is like 6 to 9, so it's 4 to 9, so it's 9 minus 4 plus 9 minus plus 9 minus plus 9 minus 5 plus 9 minus 6, so it's 45 minus 4 minus 5 minus 6 minus 7 minus 8 minus 9. What the? Hello? So this is 45, so it's 40, 36, 30, 23, 15 minus 9 is 6, so it's 6, and then it's the same thing, but instead of 4, it's 4, so it'd be 36 minus like 3, wait, what? And minus 1. We can do a 3. So it'd be 3. Yeah, wait, so it'd be 36 minus 5 minus 6 minus 7 minus 8 minus 9. So that's 30, so it's 30, 25, 18, 10, 1. So it's 7. What? Just 7 possibilities. Okay, I guess I'm not understanding this one as well. Like, that one? I didn't know they got hard so fast. You know, I thought I'd have a bit of a chance with this one. How many questions are there? Oh, there's 25 questions. Okay. That's a lot of writing. Alright, you know what? Let's just keep moving. How much time do we have left? 16 minutes left. Ricardo has 20 coins, some of which are pennies, 1-cent coins, and the rest of which are nickels, 5-cent coins. And the rest of which are nickels. He has at least 1 penny, at least 1 nickel. What is the greatest? What is the? Wait, what? Okay. So there's n pennies. 20 minus 20 minus n nickels. Nickels. So then n cent. What is the difference in cents between the greatest possible and the least? So and then it's 5 times 20 n cents. So the amount of money you'll have is 5 20. Oh my gosh, it's this plus this. So then it's n plus 5 times 20 minus 5n. So 5 times 20. So it's minus 4n. What's 5 times 20? 5 times should be like 5 times 10. 0 plus 3 zeros. 10,000 plus 5 times 20. That's just 100. So you get 1 for n. So then you have the greatest number of pennies. So basically, and then you have to have n plus 20 minus n equals 2020 plus n, so equals like, and it has at least one. What is the difference in the greatest possible and the least possible amounts of money that Ricardo can have? And he has at least one. He has at least 1 penny and 1 nickel. So that means if he has 1, so if you do 1 penny, right? If you do n equals, if he has 1 penny, so that means n is greater than 1, but it's less than 2020. Okay, so it's greater than 1, but it's less than 2020. So then, wait, it's like greater than or equal to 1, but it's less than 2020. So it's greater than or equal to, wait, yeah, it's greater than or equal to 1 or less than or equal to 2019. So that means we can just, I guess, start calculating. So it's like the least amount of money he'd make is if it was, yeah. So the least amount of money he'd make is if it was 1n, and then the least, and then the greatest is minus 4 2019. So then there's a difference in the sense between the greatest possible and the least possible. So then that is greatest possible, so then there's 1100 minus 4 comma 2019, and then you do and the least possible, so then you do 1 minus that, and then you says it's plus 4, so then you do negative, so then you cancel these out, so then you do 4 minus 4 times 2019, or so then it's like what, minus, so this would become minus 4 times 2018. What is the wait, what? And the greatest, oh wait, no, I'm so stupid. It'd be the greatest minus the least, not the least minus the greatest. Wait, did I do this wrong? There's incense, and then there's, so this is the amount of cents. 5 times 2020. Wait, what? So this is the least. Between the greatest possible and the least possible. So then the difference between the greatest possible and the least possible. What? What is the difference? Am I stupid? The greatest minus the least. The greatest minus the least. I guess it could be the least minus the greatest. Minus 100 for 2019. So then that just becomes 4 times 2018. So then that just becomes 8000 plus what, 9 times 9 times 8 is 72. So it's 8072? I think so. Loki, I think I did that wrong or something. I know. It's okay. How much time do I have left? I have 8 minutes left. Wow, this is like way harder than I thought it'd be. I swear the time I did the practice AMC 8, I probably just did the early problems for the practice, the other AMC 8 I did, because they were not as hard as this. Oh wait, I gotta make my canvas bigger. Let's just okay, good. Okay. Cash's birthday cake is in the form of a 4x4x4 inch cube. The cake has icing on top, and the 4 side faces. Wait, what? Okay, what? I'm gonna do. Okay, Cash's is in the form of a 4x4x4 inch cube. The cake has icing on the top and the 4 side faces, and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes. Into 64 smaller cubes, each measuring 1 by 1 by 1. Okay, so okay, I actually understand this. So the inside, so it's like we'll have icing on exactly 2 sides. So there's a thing in the middle. These will all have like 1, 2, 3. So these will all. This is like 1, 2, what? 16. So this is 16. will definitely not have at least 2, because these top ones only have this. Wait, what? Yeah, this top one only has 1. The bottom one has 0, and then the middle ones have 0. So then that is a wait. What? Wait, this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so it's 16. So there's 64 minus 16, and then all the ones on the top have, how many do they have? They have at least 3. They have 3, because one on the top and then one on either side. So that's 1, 2. That's 16 minus 4, so it's minus 12. So then you just get like these sides, and then each. Wait. Why am I still on the bottom? Wait, I might be wrong about this 16, because the bottom. Oh, okay, so it'd just be 12. So it's 64 minus 12 minus 12. So then that just leaves. Oh, whoa, wait. No, I am. Oh my gosh. I'm actually so stupid. It is minus 16 minus 12 because it's the center on the thing. Okay, so then that's all the. So then that basically becomes like these ones, like in this like pattern all around. So then that's like these ones would only have 1. So that's 2 times 4. That's 8 minus 8. So that's, I think that's all of them. So that's 64 minus, what's the 16? Like minus 20. It's minus 20. Oh, minus 16 minus 20. It becomes minus 36. So then 64 minus 36. 60. So that's 34 minus 6, 28? Wait, what? How many of this have exactly on 2 sides? On exactly 2 sides. Wait, what? What did I do wrong? What did I do wrong? So, okay, wait. So all these central ones can't do that. It'd be only these ones. So it's, wait, no, I'm like 3, 1, 2, 3, 4. 3 times 4, it's 12. Wait, I did that in the worst way possible. I'm actually so stupid. I could have done that, logic that out in like 2 seconds, but I was trying to be smart about it. And maybe I was going in the right direction, trying to be all smart about it. Okay, Zara has a collection of 4 marbles. An Aggie. Oh, I only have 3 minutes left. An Aggie, a bumblebee. An Aggie, a bumblebee, a steely, and a tiger. She wants to display them in a row, but does not want to put the steely. A, B, S, T. So display them in a row on a shelf, but does not want to put the steely and the tiger next to one another. And how many ways can she do this? Wait, this is combinatorics. I should know this. I literally learned this all about this, but I forgot. I always forget about this. So does not want to put the steely and the tiger next to one another. So basically, if the steely and there's like steely and the tiger, it's like A, B, T, or like just think about it as like S, X, X, T, or S, X, T, X. So that means that and this can sort of be shifted along. So that means there's like there's 1, 2, 3, 4 positions for this. There's 4, and then there's 4 positions for this. And then in each of these there's A can be here, here. So that means it's times 2 and times 2. So it's 6. What? A can be here, and A can be here, or it can be here, here. 16. What's the combinatorics formula, bro? What's the I actually don't know. I should know this. Why doesn't that work? Why doesn't that work? Why doesn't that work? Why doesn't that work? Why does that not work? Why does that not work? Because this could be like slid around. It's S is here, here, or here. So then that's 4 different places S can be. And since T has to be a specific distance from S, and like it doesn't matter if there's, oh my gosh. Wait, let me try to figure out the rest of these problems. Not the rest of these problems, just the first 10. Or I don't know. Okay, wait, let me just kind of formula. So that means it has to be like that. So that means there's 4 positions for S to be in, and since T is a fixed distance away from S. Wait, is there like S X X T? Oh, cause that technically. So then, so this is 2 times 2 plus 4 times 2. 4 times 2, so that's 4 plus A, so that's 12. Oh my god. Wait, so I had like the right idea. I just like forgot a little bit. This is like also the same, probably the same thing, where I just like have too many of them, or no, I have too little of them right here. $11. I think I got 11 for this or something. Wait, so there's like, let me think about this. So that means there's 2, 2, 3, so 4, 2, 2, 3, 4, 5, 6, 7, 8, 9. Four to 9. So then that's, and then if you do 2, 2. Dude, cause I can't do. It's cause I can't put 2 there. Cause I don't like, they don't. If I put 2 there, it doesn't increase. So it just. Wait, that doesn't make sense. So then it's not 2, it has to be 2, 3, and then it's 2, 3, 4, Oh my gosh, I'm so stupid. This is 4 to 8, and then 5 to 9. So that means there's like 2, 3, 4. So it's like for 2, 3, 4. There's 5 to 9. That's well, that's just 5 possibilities. And then 2, 3, 5. There's 4 possibilities. So it's 5. So it's 5 plus 4 plus 3 plus 2 plus 1. And there's 6, 10, 15. It's 15. It's 15. And then now, this one I don't understand, cause if Marin is in the back, then if Marin is in the back, then so it's like Marin sat in the last car, so Marin has to be here. Aaron sat directly behind Sharon. Darren sat in one of the cars, and at least one person sat between Karen and Darren. So the thing is, Aaron has to be here. Because there has to be space between Darren and Karen. So then, if we put Aaron here, then Sharon would be. If Aaron was here, then Sharon would be here, and then that would mean Darren is here. But then Karen. Wait! I'm so stupid! That is how it works. Of course that's how it works, because if it's Marin here... Wait, let me erase this. Because if it's Marin here... If it's Marin here... There, that means this has to be Aaron, and this has to be Sharon. And this is at least one person, not only one person. So then that means Darren is here and Karen is here. So the middle one is Aaron. It's Aaron. Oh my gosh. I was thinking there has to be at least one person. That's why I couldn't understand it, because I was like, how can there be one person? Because Aaron has to be here. There has to be one person. So it's Aaron has to be here, Sharon has to be here, Darren has to be here, and Karen here, and there's no one in between them. Oh my gosh. The one, oh bro, those are so easy. Why did I'm so stupid. Okay, time to check the answer key now. Grade myself with a red pen. Let's see. Where do I see? Okay, solution? Wait, where do I see the solutions? AOPS and 2020 AMC answer key. Oh wait. Okay, I'll just go through it one by one. I don't wanna like spoil myself for the other ones. Okay, problem 1. E. Yeah, that makes sense. Okay, so I got E. I got 1 correct. 2. Oh, bro. C. Okay, that makes sense. 3 is, I think, is D. Oh yeah, I was literally thinking about this in my head. These parentheses, bro, because I do that in chemistry. So D. Okay, so I'm doing I mean, these ones were the pretty easy ones, so I wasn't thinking I got them wrong. Though I could definitely do them in a much more efficient way. Okay, I got D, 3, 4 correct. 5 is C. Six is the first one I actually struggled on, but I think I got it correct. It should be Aaron. Yes. Okay, I'm actually happy. Wait. I didn't circle it, but if you go back into when I solved it again, I said it was Aaron. So for 6 and 7, yeah, both of them I kind of went over the time limit for, but let's ignore that. Okay, wait, I'm actually proud of myself for this. Like, oh my gosh, bro. But I'm also kind of not proud of myself for it, because I, like, fell for this. I misread it. And then, oh, let's go, bro. This, again, I also, like, fell for, like, such a stupid, like... it's literally just, I literally remember thinking, like, oh, it has to be it can't be 2 and 2, because that's probably, it's not the same number. It doesn't increase. But then I still used 2 and 2 in my, like, counting. Oh my gosh. Okay. 8, I got C. Yes. I got C. And then 9, I got A. 12, but what? Wait, it's D? Okay, notice that. Okay, so it's D when I got 12. So it's not that. It's D20. Okay, wait. Notice that for a small cube which does not form part of the bottom face, it will have exactly... Notice that for a small cube which does not form part of the bottom face, it will have exactly 2 faces with icing on them. Only if it is one of the 2 center cubes of an edge of the larger cube. There are 12 minus... Wait, what? Wait, what? I'm not understanding that. The following diagram shows 12 of the small cubes having exactly 2 faces with icing on them. Oh! Whoa, wait, no, I don't understand. Notice that for a small cube which does not form part of the bottom face, so if you're not the bottom, if it's not the bottom, if it's not part of the bottom face, it'll only have exactly 2 faces with icing on them, only if it is one of the 2 center cubes of an edge of a larger cube. So it can only have 2 if it's here, if it's only... So it's 1, 2, 3, 4, 5, 6, 7, 8. So yeah. So then there are 12 minus 4. Oh, okay. So yeah, that makes sense. Because take away the entire... Or as we exclude the 4 edges of the bottom face. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12. You exclude these 2 from the bottom. and then what else do we exceed? So it becomes 1, 2, 3, 4, 5, 6, 7, 8. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8. Okay, that makes sense. You exceed these two in the corners. So then, but that would be on, and then you multiply that by 2, because there's on the back side. And we see 4 of the corner cubes have exactly 2 faces with icing. What 2 corner cubes? We can see that only 4 corner cubes have exactly 2 faces with icing. So it's this and that. So then, is it like on the other side, and then corner have exactly 2 faces with icing? 1, 2, 3, 4, 5, 6, 7, 8. So then you reflect that on the other side, and then is it these? Oh yeah, it is this. Okay. So this is okay. That makes sense. I understand it now. But how did I get it? What was I thinking? I was thinking too complicated. Like, I wasn't reasoning it out. Like, I was just stuck on trying to subtract from the middle. I like immediately thought of this, and I was trying to be clever. So then I was trying to think of it that fits this in, like, subtracting all the center cubes out. Okay, so that makes sense. Let's see. So it's 12. Yeah, it's 12. Yeah. Okay, so that's nice. I got. How long is this recording? It's 57 minutes, so it should take 40 minutes to get. It takes 40. You have 40 minutes for all 25 questions. But I spent like 50 minutes on 10 questions. So then I got like 5 minutes per question per queue, rather than like. Oh wait, I spent like more than 5 minutes. Yeah, I spent like 5 minutes per question. Let's say, when you're supposed to spend like, what's 25 over 40? So it's like, wait, no, it's like 40 minus 25. 40 minus, it's like 20 plus, wait, it's like 10. It's 4 divided by 2. What is 40 divided by 25? 40 divided by 20 is 2. So is it just 2.5 times 2? So it's like 40 divided by 25. It's 1.6. So you're supposed to spend on average like 1.6 minutes on each question. So that's like 1.6 times. So 6/10 is 6/10. 6.6 times 60. So 1 minute and 36 questions. So you're supposed to spend 1 minute and 36 questions. 36 seconds on each question per. Okay. So, and also I spent 5 minutes per question and I got one of them wrong. So, yeah, kind of cooked. But that was fun. I might do the rest, or I'll probably do AMC 10, because Yeah. No. Oh wait, and also these are the first 10, and it gets harder overall. Like each question gets harder from the last. So the last like 10 questions would be like much like 2 times as hard as these probably. So it'd probably take me in reality like much longer to complete all of them. Anyway, that was fun. I was inspired by, what was that? Silver math problem guy. Okay, I can't find it right now, but there's this guy named Silver who has this YouTube channel, does like integration B problems, but yeah, I got inspired by him. So yeah, thank you for watching. Hopefully, if I ever edit this and release it,